This is going to be a video on how to calculate average speed in one of our physics problems. So I have a big question here. I'm going to ignore it. I'm going to go right to what am I looking for. And again, I'm using my 6 steps. What am I looking for? What's the formula? Plug the numbers in, check the units, do the math, and make sure it answers the question. So my average speed, the formula for average speed, what am I looking for? Formula average speed. So speed is V, AV, and the formula is distance over time, just like it is for speed. Next, I need to know my distance. Well, we're going to assume from the question it's 1/4 mile. So I'm going to go 0.25 miles. Over our time, and if I read the question real quick, said the return trip took 1 minute 15 seconds. I'm going to go 1 minute and 15 seconds. Now, step number 4 is check our units. Minute and miles over minute seconds. We can't really do that. So we need to convert this to either minutes or hours. I'm going to convert it to hours. So I'm going to take this 1 minute and 15 seconds, convert it to 1.25 minutes, because that's 1/4 minute. And then I'm going to divide by 60. And that's going to give me 0.02 hours. So our final formula is going to look like this. 0.25 miles over 0.02 hours. When I do the math on that, or type it into my calculator real quick, I end up with 12.5 miles per hour. Using this same question, we're going to calculate average velocity. Now remember, this is going to be a little different. Average velocity is vector displacement. I'm just going to write displace over time. And vector displacement over time means I have to have a magnitude or a measured value and a direction. So from our question, I want 295 miles an hour, don't need it. I want 1/4 miles. Hey, it's so cool. So I've got 0.25 miles. And that racer looks like went west. So we're going to go west. So now I have a direction. Then I'm going to go back to the pits, 0.25 miles east. And we did that. We really don't know our time. But here's what's neat about average velocity. Is average velocity, if I have a vector displacement going one direction and a vector displacement of equal value going another direction, they cancel out. So it really doesn't matter what my time is, because I got a 0 on the numerator of my fraction, which means that this drag racer, according to math in vector displacement, we took one direction minus another direction to get 0 and divided by time. It doesn't matter what that time is, we're dividing that time into 0, which ends up with 0. So our vector displacement for this question is a big 0. And that's vector displacement.